All right, we want now to move to a very exciting recent demonstration by Quantum Machines, where we show the first QPU-GPU integration over DGX Quantum, which implements the basic building blocks of NVQLink. DGX Quantum is running CUDA-Q, which is communicating with CUDA over the NVQLink compatible system with microsecond latency. Here is a high-level animation of the code that we ran in this demo and what happens on the actual system. So focusing on these three simple lines, but very important lines, we see how OPX1000 performs QEC cycles and syndrome measurements on the qubits. It measures the qubits every QEC cycle. And then these qubit measurements are sent using the CUDA-Q device call from OPX1000 to the GPU. The GPU runs the CUDA kernel that we see here on the right, and the result is then returned to OPX1000. Then OPX1000 can, in turn, of course, send response pulses to the QPU to correct for errors, for example, or to perform the correct conditional operations needed for non-Clifford gate, etc., etc. All right, so here is the results of the actual experiment, where we see the series of pulses, each corresponding to a syndrome measurement that is sent to the GPU, and then the response pulse, which is this pulse on the right here in purple, after we do the entire quantum classical loop, and we see that the latency is 4 microseconds. So this result that we're seeing here is on the actual scope, looking at the pulses coming out of the OPX, and showing that the response pulse based on the GPU calculation responds with 4 microsecond latency. DGX Quantum is already working in leading labs around the world and is being adopted by new players every day. So we are now very excited to announce to our customers and partners that DGX Quantum is ready for NVQLink upgrade.